a common task in electrical circuit analysis is to know the voltage across two resistors and to have to try to find the voltage difference across only one of those resistors. The key to solving this sort of problem is to recognize that the current flowing through one of the resistors, we'll call it I2, must be equal to the current flowing through the other resistor, I1, because at this V1 node, there is nowhere else for the current to go. Once we recognize that, we can use Ohm's law, I equals V over R, to write expressions for our currents, I2 and I1. And so we have I2 is equal to V2 minus V1 over R2, and I1 is equal to V1 minus 0 volts. So we often omit that minus 0 volts over R1, and of course I2 is equal to I1. We now take these two equations and we rearrange them. I'm going to opt for V1 on the left hand side, so I've got minus V1 over R2, and I've got minus V1 over R1 from the right hand side, and on my new right hand side I will put my V2 term. It's going to be minus V2 over R2. We'll turn all of these minus terms into plus signs, and so now we've got an expression V1 times R1 plus R2 over R1 R2 is equal to V2 over R2. I can rearrange that to give V1 is equal to V2 multiplied by R1 R2 over R2 R1 plus R2. Now we can simplify that. We can take away or cancel out the R2 terms, and I'm left with V1 is equal to V2 multiplied by R1 over the sum of the resistances R1 plus R2. So this is a very common expression that we're going to see again and again and again. Let's do a quick example. We want to find V1 when V2 is equal to 5 volts, and we've got resistances of 2 kilo ohms and 3 kilo ohms. Well, we can go through the same analysis that we did before, trying to work out expressions for the currents, and we would have 5 volts minus V1 over 2 kilo ohms is equal to V1 over 3 kilo ohms, and we can rearrange from there. Alternatively, we can remember that for a voltage divider, V1 is equal to V2, in this case 5 volts, multiplied by R1, in this case 3 kilo ohms, over R1 plus R2. Both approaches will give us the same answer. We're left with V1 is equal to 5 volts multiplied by 3 divided by 5. V1 should be 3 volts. Two interesting special cases to consider, and the first of those is when R1 is equal to R2. In this case, V1 is going to be equal to exactly half V2. The other case that's interesting is when R1 is much larger than R2. In this case, V1 will be approximately V2 because most of our voltage drop will fall across that first resistor. If we look at some ratios, R1 equal to 10, R2, in that case V1 will be V2 over 1.1. If we make the ratio more extreme, say R1 is 100, R2, V1 will be V2 over 1.2. 0, 1, we are getting closer and closer to V1 equal to